What if ancient civilizations possess technology that rivals our most advanced modern equipment? Picture precision cuts in granite that look like they were made yesterday. Drill holes in the hardest stone on Earth showing feed rates that match industrial machinery. Surfaces polished to tolerances measured in microns. The official story says ancient people used copper tools and stone hammers, bronze chisels and patience. Thousands of workers spending decades on single projects. But the physical evidence tells a different story. Cuts that copper can't make, precision that hand tools can't achieve, speeds that human labor can't match. Engineers have examined these ancient works. Machinists have measured the tolerances. Materials scientists have tested the surfaces. Their conclusions challenge everything we've been taught. These aren't crude ancient attempts at stonework. These are precision manufacturing techniques. Tool marks that match modern equipment, feed rates consistent with powered machinery. Today, we're examining 10 cases where ancient stonework displays characteristics of advanced technology: laser-like precision, machine-perfect symmetry, manufacturing signatures that shouldn't exist thousands of years ago. Each case has been documented by experts, measured, photographed, analyzed with modern equipment. The evidence is undeniable. Fair warning, what you're about to see contradicts accepted archaeological theory. The experts who published these findings faced ridicule. The engineers who confirmed the analysis were dismissed as outsiders. But measurements don't lie. Tool marks tell stories. Physical evidence speaks louder than theories. 10 sites. 10 examples of impossible precision. 10 cases where ancient stonework displays signatures of advanced cutting technology. The evidence exists in museums and archaeological sites worldwide. Photographed but unexplained. Measured but dismissed. Documented but ignored. The question isn't whether these precision cuts exist. Anyone can visit these sites and see them, touch them, measure them. The question is how they were made, and why mainstream archaeology refuses to address the obvious implications. Number 1 takes us to the Great Pyramid of Giza, where precision that seems impossible was achieved in stone construction. The Great Pyramid isn't just large, it's precise, incredibly precise, more accurate than most modern buildings. The base covers 13 acres, yet the 4 sides differ in length by less than 2 inches. That's 99.98% accurate. The sides are aligned to true north within 3/60ths of a single degree, more accurate than the Greenwich Observatory was when it was built. But here's where things get interesting. The individual stone blocks aren't just stacked, they're fitted with precision measured in thousandths of an inch. The joints between stones are so tight, you can't slip a piece of paper between them. No mortar, no filler, just stone touching stone with perfect contact. Engineer Christopher Dunn spent years analyzing the precision. He's a tooling specialist, 40 years of experience in precision manufacturing. His analysis revealed something remarkable. The tolerances match modern machining standards, not ancient stonework. Industrial manufacturing. The granite boxes inside the pyramid show even more impossible precision. Perfectly flat surfaces, parallel sides, square corners, measured to modern specifications. These boxes were carved from solid granite blocks, each weighing up to 70 tons. The interior and exterior surfaces are flat within 0.02 of an inch. That level of flatness requires precision grinding equipment, surface plates, measuring instruments, quality control systems. Dunn attempted to replicate the work using ancient tools: copper saws, stone pounders, bronze chisels. Even with modern knowledge, he couldn't achieve the precision. The time required would be impossible. To hand-polish granite to those tolerances would take decades per box, hundreds of worker years for each piece. Yet the pyramid contains dozens of these precision components. The workload becomes absurd if only primitive tools were used. Dunn published his findings in technical journals, engineering publications. His analysis was thorough, his credentials impeccable. The archaeological community dismissed his work. He wasn't an archaeologist. He didn't understand ancient techniques. His analysis was irrelevant. But precision doesn't care about credentials. Measurements aren't theories. The tolerances exist regardless of academic opinions. Modern attempts to replicate the work have failed. Projects using ancient tool replicas can't achieve the precision. The stones crack. The surfaces remain rough. The accuracy falls far short. Something doesn't add up. Either ancient Egyptians had technology we don't understand, or our timeline is fundamentally wrong. The evidence is there. Visible, measurable, undeniable, yet officially explained away as patient handwork and lucky accuracy. But luck doesn't create precision across millions of stones. Patience doesn't achieve machining tolerances. Handwork doesn't produce industrial specifications. Number 2 takes us to a temple complex, where the stonework displays characteristics of machine cutting. Number 2 involves precision cuts in Pumapunku, Bolivia, where ancient stonework shows signs of advanced machining technology. Pumapunku is part of the Tiwanaku complex, located near Lake Titicaca, built sometime around 600 CE, according to mainstream dating. The site features massive stone blocks, some weighing over 100 tons, quarried from bedrock miles away, transported to the construction site somehow. But the weight isn't the mystery. The precision is. These blocks display cutting and shaping that defies explanation using primitive tools. The stones are andesite, a volcanic rock, extremely hard, difficult to work even with modern tools, nearly impossible with copper or bronze. Yet these blocks show perfectly flat surfaces, sharp 90-degree angles, precise grooves cut with uniform depth. Engineer Brian Forster documented the site extensively. Thousands of photographs, detailed measurements, analysis by materials experts. What they found challenges conventional explanations. The stones display characteristics of machine cutting, straight edges that span several feet without deviation. Some blocks have H-shaped cuts, precise grooves designed to interlock with other stones. The symmetry is perfect, the measurements identical. To create these cuts by hand would require incredible skill. But more than that, it would require impossible consistency. Dozens of blocks with identical specifications. The surfaces show no tool marks, no chisel strikes, no evidence of pounding or grinding, just smooth, flat planes and sharp edges. Modern stonemasons have attempted to replicate the work using ancient tool replicas. The results don't come close. The edges are rough, the angles imprecise, the surfaces uneven. Researcher David Childress brought in professional contractors, experienced stone workers. They examined the cuts and stated flatly, these weren't made with hand tools. The precision requires guided cutting equipment, saws with uniform feed rates, grinding tools with consistent pressure, quality control measurements. One block in particular displays evidence of what appears to be machine drilling. A series of holes, perfectly aligned, uniform diameter, consistent depth. The spacing between holes suggests a mounting system, precision placement for structural connection, engineering planning, and execution. Mainstream archaeology attributes this to patient work with stone hammers, copper tools, years of careful labor by skilled craftsmen. But skilled craftsmen make mistakes. Handwork shows variation. Tool marks leave evidence. None of that appears at Pumapunku. The blocks look like they were cut yesterday. Sharp edges, clean surfaces, precision that seems fresh from a machine shop. Attempts to date the site have produced conflicting results. Some evidence suggests it's much older than officially stated, potentially thousands of years older. If that's true, the precision becomes even more impossible. Bronze Age technology creating industrial tolerances. Stone Age tools achieving machine-perfect results. The site was damaged by earthquakes and looting. Many blocks were stolen for building material. But enough remains to see the impossible precision. The evidence sits in plain view, photographed by thousands of visitors, measured by engineers, analyzed by materials scientists, yet officially dismissed as ancient handiwork. Number 3 takes us to Egypt again, where drill holes in granite display characteristics that shouldn't exist. Number 3 involves core drilling evidence in Egyptian granite. Tool marks that match powered machinery characteristics. Egyptian sites contain numerous examples of drilling work. Holes drilled into granite, limestone, basalt, the hardest stones available. But these aren't crude holes. They're precision work. Straight, uniform diameter, consistent depth. The evidence that sparked investigation was discovered by engineer Christopher Dunn, the same researcher who analyzed the pyramid precision. He examined core samples, the cylindrical stone pieces removed when drilling holes. These cores tell stories about the drilling process. What he found was impossible, according to conventional archaeology. The cores showed spiral grooves, consistent pitch, uniform depth. These grooves indicate feed rate, how fast the drill advanced through the stone. The measurements revealed something remarkable. The drill was advancing at 1/10 of an inch per revolution through solid granite. That's a feed rate matching modern diamond-tipped core drills powered by machinery. Hand-operated drills can't achieve that feed rate. The pressure required would be thousands of pounds. The consistency impossible to maintain manually. Dunn calculated the forces involved. To achieve that feed rate in granite requires approximately 2 tons of downward pressure, plus rotational force, plus coolant to prevent overheating. The ancient explanation involves copper tubes and sand abrasive. Workers manually rotating the drill while pressing down. Years of patient work per hole, but the math doesn't work. Copper tubes and sand can't maintain consistent feed rate. Hand pressure can't generate tons of force. The grooves wouldn't be uniform. Modern experiments tried to replicate the process, using copper tubes, quartzite sand, manual rotation. The results were dramatically different. The experimental holes showed irregular grooves, inconsistent depth, variable feed rates, nothing like the ancient examples. The ancient cores display characteristics of machine drilling: consistent feed, uniform pressure, controlled advancement. Some cores show another impossible feature. The groove pitch is tighter at the center than at the edge. This indicates the center was cutting faster than the outside. That's called taper drilling. It requires differential cutting speeds. The inner portion of the drill advances faster than the outer edge. Modern drills achieve this through ultrasonic vibration, high-frequency oscillation that enhances cutting at the center. The ancient cores show identical characteristics. Dunn published his analysis in engineering journals, precision manufacturing publications, technical conferences. His findings were documented with measurements and calculations. The response from archaeology was dismissal. Ancient techniques we don't fully understand. Patient work over long periods. Skilled craftsmen with copper tools. But engineering doesn't work on theories. Precision requires specific processes. Feed rates demand certain forces. The physics doesn't change based on time period. The cores exist, stored in museums, available for examination. The grooves are visible. The measurements confirmable. The evidence undeniable. Yet officially, these were drilled with copper tubes and sand. Manual rotation by workers. Decades per hole. Somehow achieving modern machining characteristics. The disconnect between evidence and explanation is stark. The cores tell one story. The official narrative tells another. Modern contractors won't even attempt granite core drilling without powered equipment. It's considered impossible manually. Yet we're told ancient workers did it routinely. Number 4 takes us to South America, where stone walls display laser-like cutting precision. Number 4 involves the megalithic walls at Sacsayhuaman, Peru. Precision stonework that appears to have been cut with advanced technology. Sacsayhuaman overlooks the city of Cusco. Massive stone walls, blocks weighing up to 200 tons, fitted together with impossible precision. The official dating places construction around 1450 CE. Inca civilization, pre-Columbian America. Before European contact brought iron tools, the blocks are limestone and andesite. Hard volcanic rock, difficult to quarry, even harder to shape with primitive tools. Yet these blocks fit together perfectly, the joints so tight that blades can't penetrate. No mortar, no filler, just stone touching stone across irregular, complex surfaces. The blocks aren't rectangular, they're polygonal, multiple sides, angles that match neighboring stones perfectly, three-dimensional puzzle pieces weighing hundreds of tons. To create these fits requires precision measurement, exact shaping, perfect matching across multiple contact points. Each block touches several neighbors flawlessly. Researcher Brian Forster documented the site extensively. He brought in professional stonemasons, experienced contractors, engineers familiar with modern construction. Their assessment was unanimous. This wasn't done with bronze chisels and stone hammers. The precision requires advanced tools, cutting equipment, measuring instruments. Some stone faces show wave patterns, ripples in the rock surface, as if the stone was heated and shaped while soft, then cooled and hardened. Other blocks display knobs, protruding stone bumps, purpose unknown, possibly mounting points, maybe structural elements, clearly intentional. The wall surfaces show characteristics similar to cast concrete, smooth, uniform, as if poured rather than carved. But these are solid stone, cut from bedrock, not manufactured. Attempts to explain the precision using primitive tools don't account for the complexity. Each block is unique, custom-shaped to fit its specific position. That means measuring each stone's neighbors, calculating angles and surfaces, cutting and shaping to exact specifications. For hundreds of massive blocks, the time required would be astronomical. Years per block, decades for complete walls, generations for the entire complex. Yet the Inca supposedly built this in a few decades, while running an empire, while conquering territories, while managing millions of subjects. Modern attempts to replicate the work have failed completely. Even with powered tools, even with measuring equipment, the precision remains unmatched. One experiment tried to fit two large blocks together using modern stone-cutting tools, computerized measurements, skilled operators. The result was far from ancient precision. The joints showed gaps, uneven surfaces, imperfect matches, nothing like Sacsayhuaman's perfection. Some blocks show another mystery, cut marks that appear vitrified. The stone surface looks melted, fused, as if exposed to intense heat, then rapidly cooled. This characteristic suggests thermal cutting, laser technology, plasma tools, methods that didn't officially exist in 1500 CE. Local legends tell different stories. They speak of gods who softened stone, made it workable like clay, then hardened it back. Technology beyond human capability. Mainstream archaeology dismisses these legends as mythology, cultural stories, primitive attempts to explain impressive but achievable human construction. But the legends align with physical evidence. Stone, showing thermal characteristics, precision matching advanced tools, results that primitive technology can't replicate. The site remains open to visitors, the blocks available for examination, the precision undeniable, yet officially explained as patient Inca stonework. Number 5 takes us to Egypt's temple complexes, where saw marks in granite suggest powered cutting equipment. Number 5 involves saw marks in Egyptian granite that display characteristics of machine cutting with advanced blade technology. Egyptian temples contain massive granite blocks, transported from quarries hundreds of miles away, shaped and positioned with precision. The blocks show evidence of sawing, cut marks across surfaces, striations indicating blade passage, evidence of how the stone was shaped. Engineer Christopher Dunn analyzed these saw marks extensively. What he discovered challenges conventional explanations completely. The saw marks show consistent depth, parallel lines across surfaces spanning several feet. The spacing indicates blade thickness and cutting pattern. But here's what's impossible. The marks indicate cutting through granite at rates matching modern industrial saws. With blades several feet in diameter, granite is one of the hardest natural materials. It contains quartz crystals. These crystals are extremely hard. They wear down conventional cutting tools rapidly. Modern granite cutting requires diamond-tipped blades, carbide tools, powered machinery generating tremendous force. Even then, cutting is slow and difficult. The official explanation involves copper saws with sand abrasive, workers pulling the blade back and forth, the sand doing the actual cutting. Experiments have tested this theory. Copper blades, quartzite sand, manual labor. The results don't match ancient examples. Copper wears away faster than granite. The blade becomes useless quickly. The sand doesn't cut efficiently. The process is extremely slow. More importantly, copper and sand don't create the patterns visible on ancient blocks. The striations are different. The cut characteristics don't match. Ancient saw marks show something else. Consistent feed rate, uniform depth, parallel tracks that suggest guided machinery. Some blocks show multiple parallel saw cuts, side by side, evenly spaced. This indicates multiple blades or repeated passes with precise positioning. To achieve this manually requires incredible consistency, maintaining exactly the same cutting line, the same pressure, the same angle. For cuts spanning feet, Dunn calculated the forces required. To cut granite at ancient rates requires thousands of pounds of pressure, plus sustained back and forth motion, plus constant abrasive renewal. The manpower would be enormous. Dozens of workers per saw, working in coordination, maintaining rhythm and pressure, for weeks or months per cut. Yet Egypt has thousands of precisely cut granite blocks. The labor requirements become absurd. The entire population working constantly just to produce the stonework. Some saw cuts show another characteristic: curved paths, arcing through thick stone, following contours that suggest flexible or pivoting blades. This indicates something beyond simple straight saws, possibly circular blades, rotating cutting tools, machinery rather than manual operation. One particularly interesting example appears at Karnak Temple, a granite block showing a cut that stopped mid-stone. The blade path visible but incomplete. The cut depth is uniform, the striations parallel, the advancement consistent, then suddenly stopped, as if machinery was shut off mid-process. This abandoned cut provides clear evidence. Tool marks frozen in time. The cutting characteristics preserved, available for analysis. Modern stone contractors examined the evidence. Their conclusion: powered machinery, diamond blades, industrial equipment, not hand tools and patience. Attempts to saw granite with copper and sand have been documented, video recorded. The process is incredibly slow, the results poor, the characteristics completely different. Yet we're told ancient Egyptians did this routinely. Thousands of cuts, perfect accuracy, industrial precision, all with copper and sand. The disconnect is obvious. The evidence doesn't match the explanation. The physics doesn't support the theory. The saw marks remain, documented in publications, photographed by researchers, measured by engineers. Physical evidence that challenges accepted history. Number 6 takes us to ancient megalithic sites, where stone polishing achieves mirror finishes using supposedly primitive tools. Number 6 involves mirror-polished surfaces on ancient granite that display precision measurable in microns. Ancient Egyptian sites contain granite surfaces, polished to extraordinary smoothness. Not rough stonework, not merely smooth, mirror finishes reflecting light perfectly. These surfaces appear on statues, sarcophagi, architectural elements, basalt, granite, diorite, the hardest stones available. The precision is measurable. Modern surface analysis equipment can quantify smoothness, roughness, average, flatness tolerance, industrial quality metrics. Researcher and engineer Christopher Dunn measured these surfaces using precision instruments, optical flats, surface profile analyzers. His findings revealed something remarkable. The ancient surfaces measured smoothness comparable to modern optical grade polishing. We're talking about flatness within thousandths of an inch, surface roughness measured in microns, precision matching contemporary manufacturing standards. To achieve this requires progressive polishing, starting with coarse abrasives, moving through increasingly fine grades, finishing with extremely fine compounds. The process demands flatness maintenance. The polishing tool must contact evenly across the entire surface. Pressure must remain consistent. Motion must be controlled. Modern polishing uses precision equipment, flat plates, measured compounds, controlled processes, quality verification at each stage. The official explanation involves sand and stone polishers, hand rubbing, patient work over extended periods, skilled craftsmen achieving mirror finishes manually. But polishing isn't just about time. It's about precision and control. Maintaining flatness while removing material requires sophisticated technique. Attempts to replicate ancient polishing with primitive tools have failed to match the precision. The surfaces achieved are smooth, but not mirror flat. The ancient examples show no irregularities, no low spots, no tool marks, just perfectly smooth, perfectly flat surfaces across large areas. Some granite statues display this polishing on curved surfaces, compound curves, three-dimensional forms, mirror smooth across complex geometry. Polishing curved surfaces is even more difficult. The tool must follow the contour perfectly. Pressure must adjust constantly. The compound must remain uniform. Modern sculptors use powered tools for this work. Variable speed grinders, flexible polishing pads, specialized equipment for different curves. Yet ancient craftsmen supposedly achieved identical results, with stone and sand, manual labor, somehow maintaining precision across complex forms. The Egyptian Museum in Cairo contains multiple examples: diorite statues, basalt vessels, granite sarcophagi, all polished to mirror finishes. Diorite is particularly difficult. It's composed of multiple minerals, different hardnesses, difficult to polish evenly. The softer minerals tend to wear faster, yet ancient diorite work shows uniform polishing. No differential wear, no mineral variation visible, just perfect smoothness across mixed materials. Materials scientist Dr. Joseph Davidovits examined these surfaces. His analysis confirmed the precision. He attempted to explain it through ancient techniques, but his explanations still required sophisticated knowledge, understanding of materials, progressive, abrasive sequences, quality control methods. That knowledge rivals modern understanding. It suggests advanced materials science, engineering principles, not primitive trial and error. Some surfaces show evidence of final polishing with extremely fine compounds, particle sizes measured in microns, finer than common sand, requiring processing and preparation. Where did these ultra-fine polishing compounds come from? How were they produced? How were particle sizes controlled? Modern polishing compounds are manufactured products, graded carefully, quality controlled, not naturally occurring in useful forms. The ancient surfaces exist, museum pieces, archaeological sites, open to examination, the precision measurable, the quality undeniable, yet officially explained as patient handwork, skilled craftsmen, years of careful rubbing, somehow achieving industrial tolerances with primitive tools. The gap between evidence and explanation keeps growing. Each measurement reveals more impossible precision. Each analysis shows more advanced characteristics. Number 7 takes us to stone vases, where internal drilling shows characteristics of high-speed rotating tools. Number 7 involves ancient Egyptian stone vases that display evidence of advanced lathe technology and precision drilling. The Cairo Museum houses thousands of stone vases. Pre-dynastic period, before the pyramids, before recorded pharaohs, before written history. These aren't crude pottery. They're carved from solid stone, granite, basalt, diorite, extremely hard materials, shaped into thin-walled vessels. The precision is extraordinary. Walls measuring millimeters thick, uniform thickness throughout, perfect symmetry, balanced forms. But here's what makes them impossible. Many have narrow necks and wide internal bodies. The internal space is larger than the opening allows access to. How do you hollow out an internal chamber that's wider than the neck you're working through. How do you maintain uniform wall thickness you can't see or reach? Engineer Christopher Dunn analyzed these vases extensively. He's a precision machinist. He understands tool access requirements. He knows what's physically possible. His conclusion: these were made on lathes, rotating machinery, guided cutting tools, not hand-carved with copper chisels. The symmetry proves rotation. Perfect circles, balanced forms, centered accurately. These are characteristics of turned objects. When you spin an object and apply a cutting tool, you get perfect symmetry. The rotation ensures uniformity. The tool removes material evenly. Manual carving doesn't produce this symmetry. Human hands can't maintain perfect circular motion. Small variations accumulate. The result isn't mathematically precise. Yet these vases are mathematically precise. Measured circles, perfect balance. When spun, they rotate without wobble. True to center, within thousandths of an inch. Some vases have complex shapes, curved profiles, S-curves, multiple diameters, precisely executed transitions between sections. These shapes require continuous tool positioning, coordinated movement of cutting tool and rotation. Essentially, CNC lathe programming executed manually. The internal hollowing presents another mystery. How do you reach inside a vessel with a narrow opening to carve wider chambers? Modern toolmakers use specialized boring bars, long, thin tools that extend through narrow openings, guided by external measurement and feel. But that requires metal tools, rigid bars that don't flex, cutting edges that maintain sharpness, precision positioning. Copper tools can't perform this work. They're too soft. They flex under pressure. They wear rapidly. They can't maintain the precision visible in ancient vases. Some vases show internal tool marks, spiral patterns on internal surfaces. These indicate rotating cutting motion, consistent feed rate, controlled depth. The spiral pitch reveals cutting speed. The tool advanced steadily while the piece rotated. The mathematics indicate significant rotational velocity. Hand-powered rotation wouldn't achieve these speeds. The momentum required would be enormous. Maintaining speed manually while cutting hard stone would be nearly impossible. One particularly impressive example is a vase with multiple chambers, internal divisions, separate hollowed sections, all created through a narrow neck opening. Creating internal walls requires extraordinary skill and tool access. You're working blind, measuring indirectly, maintaining wall thickness you can't see. Modern machinists struggle with this even using precision equipment. Borescopes for visual inspection, measuring probes for dimension verification, computer controls for tool positioning. Yet ancient craftsmen supposedly achieved this with copper tools. Manual rotation, no measurement devices, just skilled hands and patient work. The number of these vases is staggering. Thousands exist in museums. Tens of thousands were found in archaeological excavations. This wasn't rare artwork. This was common production. That suggests efficiency, reliable processes, practiced technique, not experimental attempts or lucky successes. The uniformity across multiple vases proves systematic production. Similar techniques creating similar results. Consistent quality control. Materials scientist Dr. Lori Lane examined these vases. Her analysis confirmed the precision. She attempted to explain the manufacturing process. Her conclusions required sophisticated tooling, rigid cutting implements, rotation machinery, measurement systems, technology officially unavailable for thousands of years. The vases exist. Museums worldwide house collections. The precision is measurable, the characteristics clear, yet officially explained as patient stone carving. The disconnect between physical evidence and official explanation reaches absurd levels. The evidence screams advanced technology. The explanation insists on primitive tools. Number 8 takes us to construction sites, where massive blocks show evidence of precision cutting for perfect fitting. Number 8 involves the precision-fitted blocks at Ollantaytambo, Peru. Stone surfaces showing characteristics of modern cutting and positioning technology. Ollantay Tambo is an Inca site in the Sacred Valley. Massive stone blocks, precisely fitted, multi-ton weights, positioned perfectly. The blocks aren't just heavy, they're precisely shaped. Flat contact surfaces, perfect alignment, joints so tight that water doesn't penetrate. Researcher Brian Forster documented unusual characteristics. The stone surfaces show peculiar features, not standard stonework, something different. Some surfaces display what appear to be knobs, small, protruding bumps, intentionally left on otherwise smooth stone faces. Purpose unclear. These knobs appear systematically, positioned at specific locations, consistent across multiple blocks. Clearly intentional placement. One theory suggests they're mounting points, handles for lifting equipment, attachment points for positioning machinery, evidence of construction technology. But the official explanation describes manual labor, rope harnesses, wooden rollers, thousands of workers pulling and pushing massive stones. The precision of block placement challenges this explanation. The stones fit perfectly, contact across entire surfaces, no gaps, no shimming, no adjustment wedges. To achieve this requires exact positioning, lowering multi-ton blocks perfectly, no shifting, no sliding, perfect placement on first attempt. Modern crane operations struggle with this precision. Even with electronic controls, GPS positioning, laser alignment, getting perfect first placement of heavy objects is difficult. Some surfaces show additional mysteries. Smooth areas that appear melted, stone surfaces with vitrified characteristics, as if exposed to extreme heat. This vitrification suggests thermal processes, heat intense enough to alter stone structure, then cooling to solidify, not conventional stone cutting. The blocks also display uniform weathering patterns across entire surfaces, suggesting similar material properties throughout. Consistent composition. Natural stone shows variation, different mineral densities, weathering differences, uneven surface degradation. These blocks weather uniformly. Some researchers suggest this indicates artificial stone, ancient concrete, poured rather than carved, explaining the precision and uniformity. But analysis shows these are natural stone, quarried from bedrock, transported to site, not manufactured material. So we're left with natural stone displaying manufactured characteristics, uniform properties, precision fitting, perfect surfaces. The quarry marks are visible on some blocks, scoring lines where stone was separated from bedrock. These marks suggest systematic cutting, controlled fracturing. Modern quarrying uses expansive grout, wedges and feathers, controlled explosives, creating separation lines to remove blocks cleanly. The ancient marks suggest similar control, clean separations, minimal fracturing, efficient material usage, advanced quarrying knowledge. The blocks were transported from quarries miles away, across rivers, up slopes, through difficult terrain, each weighing up to 50 tons. Moving these blocks requires incredible force. Friction must be overcome, momentum controlled, direction maintained, all without damaging precisely shaped surfaces. The official explanation involves log rollers, rope teams, earthen ramps, thousands of laborers working in coordination. But the logistics don't work. Log rollers crush under multi-ton weight. Ropes break under extreme tension. Coordination of thousands becomes chaos. Modern attempts to move similar weight blocks using ancient methods have failed. Even with modern ropes, even with coordinated teams, the blocks don't move efficiently. One experimental archaeology project tried moving a 10-ton block using replicated ancient tools, hundreds of volunteers. The block barely moved. Progress measured in feet per day. Scaling that to 50-ton blocks across miles becomes impossible. The time required would be years per block. The labor force would need to be enormous. Yet Ollantay Tambo has hundreds of these blocks, all precisely shaped, all accurately positioned, all perfectly fitted. The evidence suggests technology beyond manual labor, cutting tools for precision shaping, lifting equipment for positioning, transport machinery for movement. The sites remain open, the blocks visible, the precision measurable, yet officially explained as manual labor and primitive tools. Number 9 takes us to temple doorways, where right-angle cuts in stone show machine-perfect accuracy. Number 9 involves the precision right-angle cuts in ancient Egyptian temple doorways, corners and edges displaying characteristics of machine tools. Egyptian temples contain numerous doorways, cut through solid stone walls, granite, limestone, basalt, precisely shaped openings. The corners aren't rounded, they're sharp, perfect 90-degree angles, machine shop precision, not hand-carved approximations. Engineer Christopher Dunn examined these angles extensively, using precision measuring equipment, squares, protractors, optical tools. His measurements revealed something remarkable. The angles measure 90 degrees within minutes of arc. That's precision matching modern machining standards. Creating a precise right angle in stone requires specific tools, guided cutting equipment, verification instruments, quality control processes. The ancient doorways show this precision consistently. Multiple openings, different temples, various time periods, all displaying identical accuracy. Hand carving doesn't produce consistent right angles. Small variations accumulate. Chisel strikes create irregularities. The result approximates 90 degrees, but doesn't match perfectly. These ancient angles match perfectly, measured repeatedly, verified independently, confirmed by multiple researchers. Some doorways show another characteristic. The cuts are perfectly straight, no deviation, no wandering, edges spanning several feet without variation. Straight cuts require guided tools, rails or tracks maintaining alignment, controlled motion preventing drift, engineering rather than freehand work. The edges are also sharp, not rounded from weathering, not worn from age, crisp lines where surfaces meet, protected somehow or recently created. But these structures are supposedly thousands of years old. Stone exposed to elements, wind erosion, temperature cycling, chemical weathering. Yet the edges remain sharp, the angles remain precise, the surfaces remain flat, as if cut recently with modern tools. One explanation suggests the cuts were made differently than thought. Perhaps abrasive water jets, high-pressure cutting, guided mechanically for precision. Water jet cutting can achieve these results. Precise angles, sharp edges, straight cuts. It's an industrial process requiring pressurized systems. But water jet cutting wasn't invented until the 1930s. High-pressure pumps, abrasive injection, nozzle technology, modern engineering. Yet the ancient cuts display identical characteristics. The same precision, the same sharp edges, the same straight lines. Some doorway openings show complex geometry, multiple angles, compound cuts, three-dimensional shaping, all executed with precision. Creating complex angles requires spatial calculation, geometric planning, coordinated cutting in multiple directions, engineering design. The ancient builders clearly understood geometry. The proportions are mathematical, the relationships calculated, the execution precise. But that knowledge supposedly didn't exist. Ancient Egypt predated advanced mathematics. Geometric principles weren't formally developed until Greek civilization. Yet the doorways prove geometric knowledge, applied mathematics, engineering principles, executed with precision requiring technological support. Modern stone contractors examined these cuts. Their assessment aligned with previous analysis. Machine work, precision tools, not hand carving. One contractor stated flatly, he couldn't replicate these cuts without powered equipment, guided saws, precision positioning, modern machinery. Yet we're told ancient workers created them routinely. In temples throughout Egypt, hundreds of precise openings, all meeting modern standards. The doorways exist. They're photographed extensively, measured repeatedly, analyzed by multiple experts. The evidence is abundant. Official archaeology maintains the explanation. Copper tools, patient work, skilled craftsmen, years of careful cutting per doorway, but the math doesn't support it. The precision isn't explainable. The consistency isn't achievable. The evidence contradicts the theory. Each new measurement reveals more impossible precision. Each analysis shows more advanced characteristics. Each examination raises more questions. Number 10 takes us to the most controversial evidence, where stone cutting suggests technology that rivals modern laser equipment. Number 10 involves the most controversial evidence of all: ancient stonework displaying characteristics that some researchers suggest indicates laser or plasma cutting technology. This isn't mainstream archaeology. This is fringe theory. But the evidence deserves examination regardless of how radical the implications. Multiple ancient sites show peculiar stone surface characteristics: smooth areas, vitrified sections, surfaces that appear melted and resolidified. Vitrification requires extreme heat, high enough to melt rock, temperatures exceeding 2,000 degrees Fahrenheit. Then, rapid cooling to preserve the glassy surface. Natural processes rarely create vitrification in stone. Lightning strikes occasionally, volcanic activity sometimes. But controlled vitrification across large surfaces requires technology. Some ancient megalithic sites display this characteristic: stone surfaces showing melted appearance, as if shaped while soft, then hardened in final form. Researcher Christopher Dunn proposed a radical theory. Perhaps ancient civilizations possessed advanced energy technology, directed heat sources, focused thermal cutting. This would explain several mysteries simultaneously: the precision cuts, the impossible feed rates, the sharp edges, and perfect angles. Thermal cutting with lasers or plasma creates these exact characteristics: clean cuts, minimal tool marks, heat-affected zones at edges, vitrified surfaces. Modern laser cutting of stone is possible. Industrial lasers can cut through granite, ceramic materials, hard substances. The results match ancient examples. But laser technology was invented in 1960. Plasma cutting emerged around the same time. These are modern innovations, not ancient tools. Yet the ancient surfaces show similar characteristics: thermal signatures, melted zones, vitrification patterns, results matching thermal cutting processes. One site particularly shows this evidence: Nan Madol in Micronesia. Massive basalt structures, precisely cut, stacked in complex patterns. The basalt columns show unusual characteristics: clean breaks, smooth surfaces, geometric patterns, and occasional areas of surface vitrification. Basalt is volcanic rock. It forms from cooling lava, but these surfaces show remelting, post-formation heating, controlled thermal modification. Local legends describe the stones being flown into place: magical technology, power from the gods, sound or energy that moved massive weights. Mainstream archaeology dismisses these legends. Cultural mythology, primitive explanations for impressive engineering, nothing more. But what if legends preserve technical knowledge? Descriptions of actual technology transmitted through oral tradition, simplified for cultural transmission. Many ancient cultures describe gods with special tools: powers over matter, abilities to shape stone, control energy, technologies beyond human capability. These descriptions align remarkably well with modern technology: lasers, plasma tools, directed energy, controlled thermal processes. The similarities are striking: ancient descriptions matching modern capabilities, legendary powers resembling current technology. Coincidence or preserved memory? Physical evidence supports technological interpretation: precision cuts, thermal signatures, manufacturing characteristics, all consistent with advanced tools. The mainstream explanation remains unchanged: patient work, primitive tools, skilled labor, thousands of workers over decades. But each new analysis reveals more impossible precision. Each measurement shows more advanced characteristics. The gap between evidence and explanation widens. Researcher Brian Forster compiled extensive documentation, photographs, measurements, Analysis from multiple experts: engineers, materials scientists, manufacturing specialists. Their consensus: these characteristics match modern precision manufacturing, not ancient hand tools, not patient stone pounding, industrial equipment. The implications are profound. Either ancient civilizations had technology we've lost, or our timeline is fundamentally wrong, or we're misinterpreting the evidence somehow. None of these options align with accepted history. All challenge established narratives. Each threatens academic consensus. So the evidence is dismissed, called speculative, labeled fringe, removed from serious consideration. But the stones remain. The precision exists. The characteristics persist. Physical evidence that can't be explained away. The measurements don't lie. The surfaces tell stories. The tool marks reveal truths. Evidence independent of theories or beliefs. Whether it was lasers, plasma, or something else entirely, the result is clear. Ancient civilizations cut stone with precision matching modern technology. That capability existed. The evidence proves it. The question is how and why we've forgotten. 10 cases, 10 examples of precision that challenges everything we've been taught about ancient capabilities. From the Great Pyramid's machining tolerances to Puma Punku's perfect angles, from Egyptian drill cores to South American laser-like cuts, the pattern is undeniable. Ancient stonework displays characteristics of advanced technology, precision matching modern manufacturing, tool signatures indicating powered equipment. Consider the granite drilling, feed rates matching diamond-tipped industrial drills, spiral grooves indicating powered rotation, taper drilling suggesting ultrasonic enhancement, or the saw marks in Egyptian granite, consistent depth, parallel tracks, cutting rates impossible with copper and sand, evidence of machine cutting. These aren't isolated examples. This is systematic precision, appearing across multiple cultures, different continents, various time periods, all showing similar advanced characteristics. Engineers have measured these ancient works. Machinists have analyzed the tool marks. Materials scientists have examined the surfaces. Their conclusions align. This work matches modern precision manufacturing, not ancient hand tools, not primitive techniques, industrial equipment and advanced technology. Who benefits from denying this evidence? Academic institutions built on established timelines, careers invested in accepted theories, textbooks requiring complete revision. The implications threaten foundational assumptions. If ancient civilizations had advanced technology, human history needs complete rewriting. Established chronologies collapse. Accepted narratives fail, so the evidence is dismissed. Called coincidence, explained as patient work and lucky precision, removed from serious academic consideration. But measurements don't lie. Precision exists independent of theories. Tool marks tell objective stories. Physical evidence speaks clearly. The ancient sites remain open. The precision visible to anyone who examines closely. The characteristics measurable with modern equipment. These aren't hidden secrets. These are documented facts, photographed extensively, measured repeatedly, analyzed thoroughly, yet officially ignored, academically dismissed, publicly unexplained. The question isn't whether ancient precision exists. Anyone can verify it. Visit sites, take measurements, examine surfaces. The question is how this precision was achieved. What technology created these results? What knowledge has been lost? Ancient civilizations possessed capabilities we don't fully understand. Technology that created precision matching modern standards. Knowledge that produced results we struggle to replicate. That evidence exists. Despite academic dismissal, despite theoretical resistance, despite narrative protection, every ancient site presents more evidence. Every measurement reveals more precision. Every analysis shows more advanced characteristics. The truth emerges slowly, researcher by researcher, measurement by measurement, analysis by analysis. These 10 cases prove ancient technology existed. The precision is documented. The characteristics are measured. The evidence is undeniable. What you believe is your decision. But the physical evidence speaks clearly. Ancient civilizations had capabilities beyond primitive tools. The stones tell their stories. The cuts reveal their secrets. The precision demonstrates their technology. No amount of theoretical dismissal can erase physical evidence. No academic resistance can eliminate measurable precision. The ancient builders left their signatures in stone. Evidence that persists across millennia. Proof that challenges accepted history. Stay curious. Examine evidence directly. Measure for yourself. Think independently. Because when establishment institutions work this hard to dismiss clear evidence, that evidence deserves serious examination. The truth is carved in stone. Literally, precisely, undeniably. Ancient technology existed. The evidence proves it.